One of the things we're going to have to do in this chapter is we're going to have to solve inequalities. And the good thing about inequalities is we solve them just like equations. Like if we had 3x plus 7 equals 10, by now this should be old hat for us. Basically what we need to do is we're going to have to subtract the 7 from both sides, right? Because we want to deal with that. And so we'll get 3x equals 3. And then to get rid of that 3, we're going to divide by 3. And we're going to get x equals 1. It's going to be a really similar strategy for us when we're in this inequality stuff. But instead of having 3x plus 7 equals 10, what we're going to have is we're going to have 3x plus 7 maybe is greater than or equal to 10. Okay. So now instead of having just one number that makes this true, 1, because 3 times 1 is 3 plus 7 is 10, we're going to have a whole bunch of numbers that make this true. Here's a number that makes this true. What if x was 100, right? If x was 100, this would be 3 times 100 plus 7. Is that greater than or equal to 10? Well, that's 307. Is that greater than 10? Yeah. I could change this to 101, right? And what we'd have here is 303 plus 7. Is that greater than or equal to 10? Well, that's 310. Okay. I could do this with 101, 102, 103. There's actually infinite number of answers that make this work. So I don't want to just write out every single one that makes this work. That would take forever. What I want to do is I want to solve this like an equation, right? I do the same moves that we did before. I'm going to subtract 7 from both sides. And I'm going to have, like this, divide both sides by 3. All my same rules of solving equations hold true. And when I simplify this, instead of just guessing checking numbers here, if I solve it, now I'm just saying, well, you know what works? All the numbers that are bigger than 1. So this is a fine answer, but a lot of times we're going to be asked to put it on a number line. So on our number line, it'll look like this, right? And we'll have like -1, 0, 1, 2, 3. We want to graph this thing. Now, here's my spot at 1. Sometimes we're going to use an open circle, and sometimes we're going to use a shaded circle, right? We're going to use a shaded circle, a filled-in circle in this case because 1 itself is a solution, because 1 is greater than or equal to 1. If this wasn't there, if it was only the numbers bigger than 1, I'd use an open circle to show that 1 itself wasn't a solution. But because I have that or equal to sign, I'm going to just shade that in. Now what we're looking for is which way do we shade all the numbers. Like I said, I already know 100 and 101 work, so I'm going to be shading to the right. But if you didn't want to check numbers, you could just say this. This X represents like the numbers that work. So the way that we shade are all the numbers bigger than 1, right? So we're looking for the ones bigger. So we're just going to shade up like that. And that represents all the numbers that, that make it true. There's a couple little tricks to these. Kind of make our life, I don't know, a little semi-difficult at some points. I mean, not all the equations first off are as easy as that one. You could get something like this. Right? So if you're trying to solve this equation, we just got to treat this thing like it's an equal sign. And there's going to be some exceptions to that, but not quite yet, right? So we have negative 3x minus 15 greater than 2x minus 25. I got x's on both sides, and I want to take care of that. So what I'm going to do here is I'm going to add 3x to both sides because I don't want to have 2 x's in 2 spots. So I'm going to get negative 15 is greater than or equal to 5x minus 25. So that's one of the ways that these equations can become more complex. Just by giving us harder equations. And so now what I'm going to do is I'm going to just divide both sides by 5. You can kind of see like that. And when I do that, I'm going to get this as a solution. 2. So when I'm coming up with a graph for this one, I got to just be really careful. Because for one thing, the x is on the right side, so that messes with some people. But also, what I have here is I'm looking for all the numbers. Like this is my line, right? 2 is bigger than my line. So I'm looking for all the numbers that are smaller than 2. Right? So it's going to be an open circle because 2 itself isn't a solution of this. 2 is not greater than 2. Right? So it's an open circle that indicates that every number, but not that one. Right? And I'm looking for all the ones less than, so I'm going to be shading left. Right? So just be careful. A lot of people will say, like, you know, if it's a greater than, we always shade up. But here's an example where the greater than sign, where it's a greater than sign, but since our x is on the right side, yeah, we're gonna have to shade left.